to statistics, or as I like to call it, puntistics. Today we'll be doing measures of center, where we'll be finding the mean, the median, and the mode. Let's check it out. Okay guys, so once again we're doing the measures of central tendency, which is finding the mean, the median, and the mode. To define these terms, we'll start off with the mean, which is the sum of a set of data divided by the number of entries. A median is the middle value, or the mean, of the middle two values of the data when ordered. And finally, the mode, the data that occurs with the greatest frequency. Also, mode may have two, which we call bimodal. Starting off with mean, it is represented by x bar equaling sigma of x divided by n, which would be the number of scores. For example, we have this set of numbers starting with 32 ending in 43. In order to get the mean, we would add up all the numbers, which would in turn equal 360. After finding the total, we would divide it by the number of entries, which is 9. Therefore, 360 divided by 9 is 40. The mean is 40. On to median. For example, we have the set of numbers starting from 32 ending in 43. The first step in finding the median is ordering the data set from least to greatest. After we order the data set, we find how many numbers are in the data set. If there is an odd number, we will find the median in between the numbers. If the number is equal, as represented in the following example, we would have to divide the two numbers in the middle by 2, giving us 39.5. Once again, the mode is the data entry that occurs with greatest frequency within the data set. As you'll notice, the number 43 is reoccurring. Once we count, we notice that 43 happens to show up 3 times. Therefore, the mode in this data set would be 43. To throw this term in, we have outliers, which would be any data entry that is far removed. An outlier can cause gaps in between a data set. So now we're going to compare the mean, the median, and the mode. For example, we gave you a data set, numbers starting from 32 all the way to 81. We have the mean, once again represented by x bar equaling sigma of x over n. Once we total all the numbers in the set, we get 606 and the number of entries, 14. We divide 606 by 14 to give us approximately 43.3. The median, which is 42.5, is found by dividing the two numbers in the middle, which would be 42 and 43, and dividing it by 2. Once again, the mode here is 43, as 43 is shown in here 5 times. We now have the mean of frequency distribution, represented by x bar equaling sigma x times f divided by n symbolizing E of f, where x and f are midpoints and frequencies of a class, respectively. The first step in this process is to find the midpoints. We find the midpoints by adding the lower limit to the upper limit and dividing by 2. The second step is to find the sum of products of the midpoint and the frequencies. The third step would be to find the sum of frequencies. Lastly, we find the mean of the frequency distribution by adding in the whole formula and plugging in the answers. As an example, we plugged in some numbers into a chart, where x would be representative of the first column and f being the second column, the third column representing x times f. In order to get the answer, we use the third column, representative of x times f's total, and divide this by the sum of frequencies, which is represented by the number 37 in this case. Therefore, we divide 1182.5 by 37, giving us approximately 32. Here we have the weighted mean, where the mean of data set whose entries have varying weights. This is represented by x bar equaling sigma of x times w divided by sigma of w. For example, Gloria decides to start making ribbons during her spare time to sell. Since she was just starting school, she decided to make ribbons for the 4 weeks leading up to her first day of school. With x representing how many ribbons she made, w will represent the weeks worked. Underneath, we have 3 columns. In the first column, we have x, representative of the ribbons she made, and w, representative of the weeks she worked. In the final column, we have w and x multiplied together. In order to get the answer, we plug in w of x, which equals 133, and divide this by e of w, which is 10. In short, we get 133 divided by 10, which is approximately 13.3. Here we have the shape of distributions. In a symmetric shape, a frequency distribution may have a vertical line drawn through the middle of the graph, and the resulting halves are approximately mirror images. In a uniform or rectangular shape of distributions, a frequency distribution's entire entries or classes have equal or approximately equal frequencies. In a skewed shape, a frequency distribution is skewed if the tail of that graph is longer on one side in comparison to the other, whereas we will have a distribution skewed to the left, where the tail elongates towards the left, or skewed to the right, where the tail elongates towards the right.